So it's a workshop for touch designer and very beginner level. So this is probably what you see if you open up the software. If you haven't never opened it, congrats, you opened touch designer for the first time. And this is probably what you're gonna see. And so the way touch designer works is that there are these boxes or nodes that are called operators. So essentially, operators takes input, so like those things wires that plug into it, and sometimes gives an output, like this kind of thing that go out of it. And this kind of window is just previewing what kind of output is being outputted by this node right now. And there are some special nodes. So see, this one's purple, this one's green. The reason is that they're from different operator family. So if you press tab, you're gonna open up the window for adding a new node to this project you're doing. And you can see there's a couple categories. The first is comp. The second one's top, chop, stop, mat, that, custom. It might be really confusing that what it means. So top means texture operator, and chop means channel operator. Stop means I think surface. It's more about like geometry and like 3D models and vertices and faces, that kind of stuff. And mat is kind of go with stops. So it is a material operator, and that is data operator, and custom is what you can like customly script those in Python, which we're not gonna get into today. And there is also comps. Comps are more complex kind of data or operators that are built out of other operator. So you, let's say I can select this one and right click. There is called collect selected. And essentially this is basically like group all the nodes that you're selecting here into one comp. So if you click on that, you can see it change into a base, which you go to the comp. You can see there's in the other section, there's something called base, which is kind of like a folder or a container that contains this group of nodes. So it's essentially, after you collapse it, you essentially it does the same thing as it did before. But if we have multiple nodes, we kind of want to organize our project, we can put them together into this base. And to go into a base, I don't know if everybody has their mouse here, but if you just scroll in to zoom in and zoom really in, you're gonna go into this base. So you see there are inputs, which are the inputs that go into this base comp, and also output, which is the output that will go out of this base comp. You can see this is the node we collapsed it before. And if you want to get out of the comp, you can just scroll out and you can get out of it. So yeah, this is kind of the basic interface for touch designer. And after you click on one of the operator, you can see all its parameters on the side. You can press P to hide it or unhide it. And yeah. So for today, most of our things, or actually all of the things I'm talking about, is going to be in the top category. So texture, which are used to generate visuals. And to start from scratch, we're just going to delete everything. So if you select them and press delete, they're going to become select by box selecting using left mouse button. And then you can press tab to create a new operator. For here, we're going to create, first I'm going to create movie file in. So you can type in here, it's going to search for whatever is matching your search. So if you search MOV, it's going to go movie file in and movie file out. We're going to go with movie file in. And you can see there's a banana here. That's like the default picture that is located by this top. So the purpose of this talk essentially is just to bring in an external either movie or photo or JPEG or PNG, whichever format you have that it supports, to bring it into Teacher Center. And this is a static image. So, also one thing I forgot to say is that if you click on this tiny blue button underneath, especially most tops, I think all tops have it, you're going to display it in the background. Question?
Yeah, I have a node I can't delete. What is the geo one?
Can you select it? Box selected.
What box
So if you drag it across, also for the geo, if you click the right lower corner, there's a star. If you click it,
Yeah.
it's gonna go back to.
Oh,
And then you
okay,
can
got it,
just-
I got it.
That is something that I'm gonna get into later. So which is in SOPs, or even this one, like all the operators next at the lower right, there's a viewer active. Essentially, after you click it, it's gonna make this operator function kind of like a button.
Okay.
So we're gonna get into that slightly later about what that means. So here, everybody got their banana on screen. And there is, so let's say we want to move this banana around. We can, another thing to add a note is to go to the output section. And you can drag it, but there's nothing to attach to. But you can right click it on where the output is. And you can add a node from there. It's the same interface, but once you add a node from this one, it's going to be automatically connected to the one that you're clicking on. So here we're going to add a transform. So this is kind of like the move tool in Photoshop to move picture around. Here we're going to actually not display the movie file in, because we're going to display the output of the transform. So here it's going to be the same because we haven't done anything yet. But in the transform, we have like a bunch of parameters we can have here. The first one is just translate, which means to move this one around. The first is on x-axis, and this f means it's moving in the fraction. So if you type in 0.5, it's going to move to the left, half width of the entire picture. So here if I move 0.5 into the second one as well, it's going to move up. So the positive means right, so for the x-axis, the positive means right. For the y-axis, the positive means up. So if I change the 0.5 to minus 0.5, it's going to be on the other side. So other than that, there's also, let me put it back in the center again. So you see there's a C. There's also rotate. You can rotate it by any kind of degree. So one input that's taken here is actually degree. So if you put like 180, it's going to be upside down. And you can also use a slider here to adjust the rotation you want. I'm going to put, I like this angle. So there's also scale, which is pretty self-explanatory. You can zoom in, basically enlarge or squeeze, shrink the image. So we can do scale 1.5 maybe. So it's going to get longer on axes. And this one is going to make it even bigger. So here you can see like when we do 1.5 here and 1 here, it's actually elongating in the y-axis. The reason is that the transform order is being applied as scale, rotate, translate. So it means scale applies first. So it's gonna essentially scale it in this kind of configuration in the x-axis and then rotate it. So that's why it's like that. But you can also change it to whichever order you want. So yeah. So, cool. And another thing is that if you click on, for example, the rotation, and you can have this drop-down menu, which is a bigger window for you to type in stuff. And in this here, you can only type in numbers, but also expressions in Python. So, for example, one of the most commonly used one is called ABS time. T is capitalized in camel case. Dot seconds. So this means that the ABS time dot seconds is the second that has been passed when you open this, since you open this project. So here, like I opened it like about 10 minutes ago, so it's like 600 seconds. Another one that's pretty common is ABS time dot frame. So which is the frame count that has been passed by since the opening of this project. And see down here, it's also the frame going up, but now the timeline is set to between the 0 frame and 600 frames, so it's going to keep looping. But this ABS time dot frame is not going to be looping because it's the absolute time since the opening of this project. So you can see this bell is spinning, which is, I don't know, pretty ideal. And another thing that's pretty common to use is called a null. So a null is essentially a placeholder. It copies the reference of this picture. It doesn't do anything to it. It just copies its input. But the useful thing is that if you want to see the results of our node tree, we can undisplay transform but just display null. And here, for example, add another transform between the null and the first transform. Oh, we can also right-click on the connection to insert a node in between. Forgot to mention that. And here, if I do a translate 0.5, it's gonna automatically display the results on the background because we're displaying the null, which is the only node, the end of node tree, the outcome we were trying to get. So yeah. So from here now, we don't have to undisplay everything. We try to add a new node. Cool. Here's another thing is on the right side of the node, there is 4 buttons. The first one's viewer, and to toggle on and off for the viewer, because turning it on, especially when you get a lot of stuff, can take a lot of your processing power away. So when you don't need them, you can also just undisplay them. This one's clone immune, which means that there is a conf called replicator, which essentially can replicate the nodes, but it's gonna also take more processing power to click clone immune. It's gonna go very slightly faster, but also immune to cloning, which we're not gonna get into today. And the one I'm gonna talk about is the bypass, which essentially, if you click on this node, essentially it's gonna bypass the process, basically turning it off. And now it's just functioning like a null node, essentially. And the last one is lock. So it's gonna lock whatever, when you click it, you're gonna lock the output of it in frame, and it's not gonna update from that point, but you can also unlock it. And so yeah. And for now, we're gonna just throw away this transform because we don't really need it. And there's also a bunch of like image filter we can add to it. The most common one is like adding a node called monochrome, which is essentially turns it into a black and white picture. And yeah, we can bypass that for now because it's not gonna. I like to see a yellow banana. And there's another interesting top called displace. So when I put it in, it's not gonna do anything for now because you can see it takes 2 input. So the first input is the image to displace, and the second is image that is used as a coordinate for displacement. So for example, I can drop a constant top, which is essentially a holder for a constant color. So if I plug it in as a second, so if you drag from the output and plug it in as an input for the displace node, the banana's gonna go away. The reason is that the displace weight is set to too high. So here, if we change it to 0.1 and 0.1, the banana's gonna come back. So how displace node works is that it takes in this, for every pixel that's in its original picture, you're gonna try to locate the pixel at the same location in the second input and use the pixel value use it in the second input to use it as a picture to display the first one. So here, the RGB value in the constant, the R is going to displace the banana on the horizontal side. So here, if I change the color to like 0, 1, 1, you can see that it actually goes back to the center, or actually 0.5. So because here, there's a source midpoint in the displace node that essentially says, okay, so the 0, no displacement means that, or actually 0.5 in the RGB value means no displacement at all. So if I change everything in a constant to 0.5, you can see it doesn't do anything. But if you want to move it to the move it along the x-axis, we can change the value to like 0.7, and it's going to move to the right, to the left actually. Okay. Yeah. Cool. And you may see like this kind of similar to transform, but the interesting part is that it can actually use a pattern in this constant. So if we remove the constant and we plug in the most interesting top that we're going to see is called noise. So noise essentially is basically a Perlin noise in 2D texture. And if you plug that in as the displace, it's gonna distort the picture because every single pixel in this displaced texture has different values. So essentially every pixel in the banana picture is being moved at a different kind of magnitude and direction. So it kind of creates this kind of weird picture. And we can also turn off the monochrome on the noise. Essentially means this noise is going to be colorful. So all the RGB channel in the noise are going to be independent. This means that the pixel in the first image is going to be distorted on the X and Y axis independently, which means the look is going to be a little bit more organic, in my opinion. And yeah, and also because to noise, there's a bunch of other things we can experiment with. So the first one I would say is the amplitude. Essentially means how big the noise is going to be, how strong the noise is going to be. So here is output. I don't know if I should get into it. So here, if you go into essentially every single top, I think except null, has this comment page. And there's a thing called pixel format. So here, default is going to be using 8-bit RGB, A value, I think. And here we're going to change it to 62-bit float. The reason is that 8-bit RGBA doesn't encode negative values, but if we are going to use it as a source for displacement, it's better to use something that encodes the entire range of the number line. Yeah, because we sometimes want negative values, and if you use 8-bit, it's going to have some clipping. So here again, if you go back to the first half of the noise's parameters, we can adjust the amplitude. You can see if it change amplitude to 0, it's going to be no distortion. If I gradually increase it, it's going to become more and more distorted. So I think this is a pretty good distortion level. And I'm also gonna go back to the transform and make it smaller because it's taking up too much of the screen. So you can change to 0.7 maybe. Okay. So it's mostly in the center, which is kind of what I like. And done. So here is this place. Another really common technique we're going to get into is called feedback, which is, I think, one of the most useful node in the entire program. Not really, but it's really useful. So here we can click anywhere and find the feedback node, drag it in here. So we can plug the displays into the feedback. Then we can see the feedback immediately captures one frame, but it kind of stops. The reason is that the feedback, so the input is only the initial frame for the feedback. Because when on the feedback, there is a button called post in the parameter side. And every time we post it, it's going to copy the texture from its input. But then its updating texture is actually depending on the target top, which we're going to get into Slyvia after. So, or actually, we can get into it now. Let's drag. So we click on noise, click on the null, and drag it into the target top. So you see, now this feedback is updating because every single frame it's grabbing the input from this target top and overwrites what is in the feedback. And you can see, like, you want to say, like, oh, so what's the significance of this? The point is that if we drop a composite top, composite is essentially just like Photoshop layers. It can basically, it takes a arbitrary amount of input, I guess more than one, and it basically adds those tops, the output of those tops together. So, for example, I can connect the noise to it, I can get the transform to it, and let's see the results of it, just for now. So you can see when it's set to multiply, it actually multiplies the value of this banana over the noise that I'm using as a second input. And well, there's also a bunch of blending options that you can choose from. Another is called over. Oh, essentially it means like it's called like Photoshop layers. It uses transparency to layer out inputs. But here, since we put the noise output on top of the banana output, noise input on top of the banana input, so it's actually over it. It goes over it. But we could click here to swap the order that is being inputted. So here now, you can see the banana is actually being drawn on top of the noise. And it shrinks its aspect ratio because the composite node usually uses this last input as the dimension of the output. So for that, we can go back to the noise, go into its common, and change its resolution. So I think for the default movie file in, the resolution is actually 2080 by 720. So here we can see that it actually goes back to normal, or as what we want it to be. So there's a banana spinning on top of the noise. Not that interesting. But when we disconnect everything, to disconnect something, you just right click on the connecting line and it's like disconnect. It's gonna disconnect everything. So you disconnect the composite node and connect the output of displace node and the output of feedback together, and use that as the input for the null. You can see that it's actually drawing whichever that is, okay, over. Oh, actually, that is over. So it is using the so it is drawing, so essentially, this is gonna be hard to explain. So which the outcome of the displace node is gonna go into composite node, composite itself with the feedback, and goes into the null. And then the null is gonna go back to feedback. So essentially it's like a drawing board. The feedback serves as a drawing board and you keep drawing things on top of it without removing your past input. And so it keeps just overlays on top of it.
How did you connect the feedback?
Connect what?
Connect the node to the feedback.
You select the feedback, and so the parameter is set to feedback, and you drag the null, click on it, and hold it, and drag it in there. Yeah. So I guess the display is a little bit confusing. I'm gonna remove this one. So you see here, the banana is drawing a trail of his spinning onto. I guess that's more easier to see, that it kind of moves. Anybody familiar with P5? That if you don't redraw the background, it's gonna keep drawing over it. That's kind of what it does.
Can you explain the flow again of what connects into what to make it redraw?
You want it to be redrawn or no?
I got lost when you disconnected the comp and then.
Oh, okay. Yeah. So for it to kind of overlap its outcome,
Yes.
you essentially want to composite whatever you're drawing, essentially is displace node output, into a comp, and also the feedback, which is a drawing board, into the comp. And the operation you're gonna select here is over, so which means you draw things on top of the drawing board. And then you're gonna draw, the drawing board is gonna go into null, which is essentially just a placeholder for data. And then this data is feedback into the drawing board.
Okay.
So the feedback is kind of like a placeholder or like a playground for people to draw things on.
And what's the distortion in the background? I'm only getting a spinning banana.
You can just hit reset. And then since this feedback is always constantly storing data, so if you hit reset, it's gonna go back to its blank state, but also grabbing the first frame of this input. The input is being connected to. Yeah. Cool. I don't know. This banana seems pretty meditating to look at. And yeah, and also, but the thing is, if we want this kind of trail, but also we don't want it to stay for forever, there is another node called, we insert between comp and null. But let's turn off the display for comp because it's the same thing for now. Called level. So level is essentially, if you use After Effects or Photoshop, it's the same thing. It has brightness, gamma, contrast, also opacity. You can go to the post tab. So you can decrease the opacity of the thing that you're doing it to. Like I can drop it to like 0.95 or something. And then you can see there's like a very faint trail of the banana. The reason is that every time it goes through, it's gonna reduce opacity and then go into null. And then go into feedback. And then it's gonna go back. So every frame that's even earlier is gonna get like its opacity reduced again and again and again in this level node. Yeah. And cool. And another thing is to make it even look fancier. There's another node called blur. Essentially blurs the image. If you put it behind the level. Actually, let's put it before the level. So it's like the trail of the banana is actually getting blurred. So if you turn back the opacity back to 1, you can see that the trail is just getting blurred and keep getting blurred again and again and again because there is a feedback that's going on that loops the older frames getting more blurred over time essentially. And if you get the opacity back to 0.95, it's just gonna look like a blurred trail, which kind of looks cool. And there is, so we talk about transform. Let's say before the blur, and I actually input a transform, insert a transform node. I should have done this in the beginning. Essentially, if you're gonna, for example, do the translate thing, you can see that the trail actually got moved to the side for every frame, every loop it went in the feedback. So every time it got pushed to the side and then got pushed to the side again and coming to the side again. But you keep drawing new ones on top of each other so you can get this like line of bananas. When one's like kind of big value, if you're going to 0.05, you can see there's more bananas. And the interesting thing is that if we put it in the scale, especially something bigger than 1, like 1.05, 1.05, it's gonna have this radiating kind of effect from the banana because every time it goes through the feedback, it's making the picture larger. So the older frame is gonna keep getting larger, all getting blurred and getting reduced opacity. So, but you have new one that's in the center. So yeah. If we turn the displays back on, it's gonna be a kind of interesting visual. Yeah. Cool. Another thing is to realize is that it's kind of staying in the same place because the noise here is static. So after you distort it, there is actually a pattern that you're gonna see after distortion. But just like every parameter, the noise actually has a transform as well. Essentially that means when you're sampling the noise, you're using the coordinate of the noise field, and this is the coordinate of the noise field's transform. So let's say if I could translate to ABS time, seconds. Wait. Typo. The noise actually is gonna move from left to right. Since the noise field is moving left to right and the noise continuous, so that you can see in the noise texture is kind of scrolling through. And if you put it in the second, it's gonna scroll down. And I guess the one I'm trying to get to is if you put it in the third one, this is changing its 3-dimensional coordinate since the noise actually is generated from like a 3D texture or sampled in the 3D world. So if you put it in the third translate, it's actually gonna go through essentially like a slice of the same place, but in the 3D space. So it's gonna give like a continuous change in the noise while keeping it changing. But it's like a continuous change. It's a nice thing about perfect noise. And yeah, now we have a banana keeps splattering on our face. I don't know if you like that, but and cool. Okay. Next thing is gonna be really tricky. So before the transform blur at level, we're gonna insert another node between the conf and the transform. And that is called edge. So what edge node does is track the edge of a certain image I'm gonna bypass it for now. Or let's try it on the banana too, just to explain it what it does. So if I put the banana in, you can see the edge, the output of the edge node is like an edge detection in this entire image. And the stronger the edge is, the brighter this image is. And there is another input called comp over input. Essentially means it's gonna composite the edge on top of the banana. So that's just what edge does. And there is also another parameter called, if I turn off the upper input for now, there's another called sample step. Essentially means, so by edge is comparing the value of one pixel to its neighboring pixel. And sampling step means how much distance is between one original pixel and the neighboring pixel. So if I change it to 5, you can see the edge is kind of more blurred. Yeah. So here just explaining what edge does. So for now, we're gonna go back to our edge in between the comp and the transform. And enabling comp over input. So essentially you're getting this kind of cloudy thing. It's because every time you run through, it's gonna keep getting this feedback in the edge. So you're getting edge of an edge of an edge, but also the edge is being blurred. Kind of hard to explain why it does this, but yeah. It's a rather common technique that it's being used. And again, in between these two, we can add another like displace node. Oh. To make the picture more distorted, as you can see there's like a cloud. But if you want it to be more organic looking, there's gonna be another displace with, I'm gonna plug the same noise into it, just why not? Oh, this is too strong. So I'm gonna change the displace weight to like 0.1 and 0.1. Slightly too strong. 0.01. Yeah. So it's kind of like this cloud flowing out. And for now, there is another interesting node that I found really useful. It is called, actually for this time we're gonna add something behind the null. So let's add another null behind it. Just so that we can see the outcome without changing the display every time. So for this null, we're gonna add a lookup. So what Lookup does is essentially it looks at the luminosity of this input image 1 and use it to as an x coordinate to look up the second image. The easiest example would be adding a ramp top to the second input. So here a ramp top essentially generates a ramp. And if we connect that to the second input to lookup, essentially it's gonna change the, so you can see before this, let me disconnect it. You can see there's like this check pattern, which means alpha value equal to 0. And if I put it back in, it's gonna be like black. Because when there's no alpha value, essentially also there's no luminosity, it's gonna look it up at the rightmost side of this ramp, which is black. So now we have like this ramp, or it's looking up the texture. But if we move the ramp around, we're going to change the look of it, because the value of it being looked up is actually just based on how the ramp looks. So what I did here right now is it actually, I guess to explain it, example that's easier to explain is that add another value that's 0. I think if you use like Adobe has it's kind of similar interface. If you move it all the way to here, like halfway through, you can see that a lot of things just get blown out into white because what it means that for the luminosity value in the first input, as long as it's bigger than the position of this stop, it's going to go all the way to white because looking at this part of the texture. So if I put it here, you can see the white part just gradually getting thinner and thinner. If I put it all the way over here, everything's going to be white. So yeah, to remove the stop, just click on it and drag it off the ramp and it's going to go away. For here, I'm going to turn on, actually that's not turning on. So the thing about ramp is that I can always also change not only the luminosity, but also the color of these stops. So if I click on one stops and then turn up the saturation, so you can see I'm changing this thing entirely to red. Or a better, more aesthetically pleasing color, I kind of like this one. Or this one looks pretty good. And I can add another, actually 2 saturated. Decrease a little bit, just aesthetic choice. And another stop by clicking at any position on the ramp. I can also change it to a different color. And I like this one. And you can also change the black to a different color if I click on it. And I'm gonna have to increase the value first. But and also saturation. So it's no longer just from black to white. It's gonna be between different colors.
How would you then like make that into a texture? Would you have to like put it on a phone?
Oh, you mean as a texture for 3D model?
Yeah, or like I don't know if you're familiar with like Cantan Mapper for like projection mapping. It's like 2D mapping, and then you can make masks. So I was wondering if you could like make an effect, make it into a texture, and then use that as a mask.
Yeah, totally.
Could you go over that flow super quick? Like making it into a texture?
That's gonna get into softs, essentially the 3D world. And maybe we got a little bit of time. This is all I have for today, to be honest, and we did finish it. So I'm gonna not looking at this trippy thing for a while. So first off, very simply, there is, let's just get to the very basic. The type cube, I think cube, no, box, yeah, box. So we're gonna get a box here. If you click on the viewer active, we can actually navigate. Click on this viewer node, we can actually navigate in 3D space to look at it. It's not gonna change its transform or anything, just looking at it. And to see a soft, there is quite a lot of setup in here. So first we need a comp that's called geometry. And you right click on it. For this time you have to right click on the output of the soft to create this geometry, or you wouldn't have this input. So there's a geometry. The reason why you put it into a comp is because there is a top called render. And that's the thing that renders the 3D geometry. For now it doesn't have anything because we also need a camera comp. So if you go back to comp, add a camera, and we're gonna see this cube. It's black because we don't have texture or any light for it for now. So this camera render, if you go to the render top, you can see there's camera, render, and geometry and lights. Essentially means what are things that are involved in this render is using. So if you go back to comp, go light, and add a light to it. You can see this box is now lit up. So it adds a light to it. And the reason why I don't want to get into 3D is like it involves a lot of other stuff. Because what you're saying, if you want to do a texture, you have to get to a matte. And map essentially is texture for 3D geometry that they're using in here. So for now, I'm gonna use a fawn because fawn has the same color map that you're mentioning. So we can drop a select top. Select top essentially just copies the output of the top that you want. We drag the null, the final output that we just, this weird thing, drop it into the select. So now the select kind of copies it and just for a cleaner look. So at this fawn, we select this select and drop it at the color map. You can see this texture is now displayed onto this donut. It's a donut because that's the default for mats. And then we can drag this mat onto the geo and select material. Then this box actually, let's see, in 3D space, it actually had this texture on it. And but you can see if it changed here, it doesn't change the render because it doesn't change the camera position. But there's a very neat feature in Touch Center that is, if you click Viewer Active for the camera, you drag it around, get the angle you like, it is actually going to change the render. So this actually changed the camera's transform by just dragging around in the viewport. And here, this light is actually also changes light as well. So if you see, we got the camera, we want the light at the same angle. So we just change it to the same angle. And it's a little bit dark. Let me see. Yeah, a little bit dark. We can go to lights. Light, there's a parameter called light dimmer. It says maximum is 1. It's lying. Just type whatever value you want. Like 3, much brighter. Yeah. As for projection mapping, you kind of have to align this one to the projection and projector from the angle you want. There is a way to do it, but it takes quite a lot of time to explain and quite a setup.
Yeah, we've been like researching it. I think we're gonna use Can-Tan Mapper because it's 2D mapping as opposed to 3D, which is not as much work. So we're just like in the process of figuring out like the textures that we want. I think it's in the palette.
Yeah, I think there is. Yeah, there's a component in here that does that pretty easily. But yeah, I think. Yeah, something like tool technique or something like that.
You go under mapping.
Mapping. Yeah.
Can-Tan Mapper.
Yeah. That takes. And that's another whole workshop to explain how it works. So, but yeah, if you want to do. Oh, yeah, that's a movie file out. And whichever output you want to, like, let's say we want to export this render of this cube. I'm going to drop it in, connect it to the movie file out. And for the movie file parameter, select movie, motion JPEG, and frame, 30 frames per second. You can change to 60 if you want, because by default, Touch Center works in 60 FPS. Just turn on record. You might drop frames, and you just wait until you're done. Click off, and then it's probably saved to the same same folder that your Touch Center file is at. By default, if you don't have it saved, it's gonna be on your desktop. So here, and then it's gonna take a while to open. I don't know why. See, we got this neat little video here. So yeah.